This is a little bit of an update for you on some of the new stuff that's happening in the routing area, and what a great relief it is to be able to say routing and not routing. I put this together with Dan. One of the great things about being a consultant is that you can wear any number of hats, some of them at the same time. I'm funded by Juniper to be the routing AD. You can look at this a little bit as me banging the recruiting drum. If you're not participating in the IETF, then you should be, because you have to live with the output of the IETF. You have to try to make it work. And if it's not doing what you want, and if it's not doing it in the way you want it, then staying at home with your head in the sand is not going to get it to change. So do at least join mailing lists and shout when things aren't the way you want them to be. So, yeah, what's interesting and new? I want to talk about the progress in secure interdomain routing. It's a long way, I think, still from being widely deployed, but it's got a building momentum for deployment, and certainly in the US, probably driven by Homeland Security. It's getting a lot of excitement, but people in Europe are also starting to sniff around it. We have a new effort that got going in the last 6 months called, for some strange reason, NVO3. I have no idea where the 3 comes into the network virtualization overlays. And it's looking at data center deployments and the requirements driven by multi-tenancy in data centers. And then something we're planning to kickstart next month in Atlanta is the interface to the routing system, which is, it's kind of a spin-off from the SDN hype, and is, sorry, did I say hype? It's trying to look at providing a more flexible and generic interface into routing systems, rather than poking the forwarding table directly. So CIDR was formed on the understanding that interdomain routing is fragile. This is it's rather appropriate. This is a Google quote. 99% of misannouncements are accidental origins of somebody else's prefix. That's not too clever, really, is it? Of course, it's also possible that the occasional misannouncement is not accidental, but we wouldn't point fingers. So what CIDR is trying to do is answer these questions. Is the AS actually authorized to originate an IP prefix? So you get your announcement. Does that come from somebody that was allowed to announce it? And then, is the AS path that comes along with the route the same actual path that the NLRI came to you down? Because if it isn't, there's probably something fishy. And then the third element of that is was the protocol exchange itself, the BGP exchange, secure, or could somebody have got at it and tweaked it? And this is not the first time the IETF has made an effort to attack these problems, and something that has killed it in the past was trying to prevent all malicious attacks, trying to secure every last feature. So we've made it an explicit non-goal to boil the ocean, and just focusing on those 3 questions. And maybe later we'll come back and solve world peace. So CIDR's based on RPKI. for those of you who are not into security, RPKI works by having a public key and a private key. And if you encrypt with one, you can decrypt with the other. So that there's always secret source, a secret piece of information that one end has to use, and a public piece that the other end can use. So the idea is that the public key will be issued by the certifying authority. That's the, so when you get your block of IP addresses, you can also get a public key for it. And X509 certificates, who would have thought that X509 would have lasted this long? The certificates follow then the allocation of the addresses, so that the address prefix is signed and announced with the public key. And at the same time, we then want to authorize to sign the root as well, the root origin. So essentially, you sign the prefix with the AS number that's doing the advertisement. And there's quite a lot of debate about what these scaling properties are. So there's work done on aggregation there as well. And essentially, when you receive a BGP advertisement, you can go and look up the ROA and find out whether the person who advertised to you was allowed to advertise to you. And that way of doing it means that you don't actually have to put the signature carry it in BGP. You just operate BGP as normal, but you can then do a security lookup when you receive an advertisement. And some initial work here has suggested that this is providing a much more efficient way of doing security than ACLs. So where we are with CIDR at the moment, well, we've completed the work for building a framework for actually doing the signing. So we now understand how to do RPKI and how to sign the ROAs, and we've got an infrastructure in place for the kind of trickle down with the address allocation tree. That's all published as a bunch of RFCs. We are pretty much done on understanding how to exchange information between the RPKI and the routers themselves. So when you're a router and you want to know whether an ROA exists, whether an advertisement was kosher, we have the protocol exchange for you to go to the RPKI and find out. And now what's in progress, and there are certainly prototypes developed by a number of vendors, are the enhancements to BGP itself to secure the AS path attribute, so that you'll be able to check that the advertisement has followed the right path to you, the path it's claiming to. So it's kind of almost there. If you wanted to deploy, well, you would actually, of course, need the RPKI infrastructure out there operating, but there are signings going on, so it could be put in place fairly well. If you want to read more, go look at the charter page for the CIDR working group, sign up to the mailing list there. The CIDR working group is almost hyperactive. They meet 3 times a year at IETF meetings. They meet roughly 3 times between every IETF meeting as well. They're really charging ahead with this. If you want background stuff, there have been endless presentations on the gory details Nanog and RIPE, and there are a couple of URLs there, one of which isn't in blue. That's some fairly meaty background there, or read the RFCs, or get on the mailing list and say help, because the people who are developing this are really enthusiastic and want to make sure people understand it. So that's CIDR. MVO3. So MVO3 is looking at this rather simplistic view of a data center and trying to understand the implications of multi-tenancy. So my simple data center has at the top gateways to the outside world, and that's us, I guess. A kind of interconnect between the internet and VPN customers, and then down actually into the real data center with coming in through core nodes, usually with routing, into a top-of-rack switch, which there's a lot of argument about now whether top-of-rack switches route or not. And then down a stack of servers, each server having blades, each blade running multiple virtual machines, each virtual machine running multiple applications. So by the time you're in a big data center, you have a vast number of virtual machines. And it's clear that data centers will support multiple clients. And it's clear that there'll be multiple virtual machines. The questions start to be really the same questions that we looked at, I guess, 10 plus years ago with regard to VPNs. How do you separate the customer's traffic, and how do you separate their data? How do you make sure that the customer feels confident about that? How do you handle mobility of customers or customer resources? Ideally, lots of thought about moving VMs around, especially in quiet times, so that you can turn off servers and save power. So when we first looked at doing data center work in the IETF, data center was another of those hype phrases like cloud, like SDN. Everybody came along, everybody had an idea, they had a problem, they had 3 products, and they wanted to corner the market, but nobody quite knew what they wanted, really. I have to say some of that comes because the operating community, especially in data centers, is a little shy. The shyness comes about because of secrecy. Every data center is done slightly differently. But I think it probably also comes about because data centers might be winging it a bit. So we chartered this working group to look at finding solutions to multi-tenancy using the network layer, i.e. layer 3, IP, rather than traditional layer 2 solutions. We are, after all, the Internet Engineering Task Force and not the Ethernet Engineering Task Force. And one of the first tasks is actually to try to understand what types of services are needed in typical data centers. For example, is it an IP service that we need in the data center, or is it an Ethernet service, or both, or neither? What we're not doing in this working group at this moment is doing wide area interconnection of data centers, which is another important problem But if you put all the problems into the same working group, history shows you develop nothing. So what MVO3 is trying to do is break out deployment scenarios, usage cases for data centers, and work out what needs to be done to solve them. And it's entirely possible that we already have the tools and that we can use an IP-based VPN or an MPLS-based VPN, although I understand some people don't like the idea of putting MPLS in their data center. Or it may be that we need to develop a whole new set of tools, specific and optimized for the problems. Until we actually get proper focus on what those problems are, we're going to have real trouble focusing on solutions. So what we've done, well, the working group met for the first time in July, so it is really young. They spent most of their meeting there throwing food at each other and refusing to work together, and all having better ideas than their friends. But by locking them in a dark room and not letting them out, we've come up with a unified problem statement, which the working group is getting behind, and also a framework. So we have a starting point, and if you want to look and see the direction they're going in, and in particular, if you want to look at it and say, you're wrong, then that would be really valuable. There is an inordinate amount of noise going on around MVO3. This little list down the right-hand side of the screen is just some of the internet drafts that people have written because they've had ideas. I would say some of the ideas have clearly occurred to them in the bath late on a Friday night, and other ideas have occurred to them after they filed their patent. Others probably have a good germ of truth and will get built on. So a lot of the choice will be based on how the problem statement and the framework shape up, which is part of the reason why we had such trouble getting the problem statement to stabilize. Because if you can get the problem to articulate your solution perfectly, then your solution will get standardized. So really, we had to pull back and stop talking about solutions so that we could get the problem statement written. Okay, so much for data centers. The interface to the routing system. I'm sure you've seen various presentations on SDN over the years, with the philosophy that it should be possible to separate the application that drives the network from the hardware that drives the network, and be a little bit more flexible about what the application actually is, and provide if you like, a sort of programmable API type protocol interface between the two. So 12 months ago, we started looking at what the SDN implications would be in the IETF, and we found that nobody could actually agree on what the acronym stood for. So it's software-defined or software-driven networks. And with that lack of agreement on acronyms, there was a lack of agreement on what you're trying to achieve, how you're going to try to achieve it, what are you driving, who's doing the driving, what is the big picture architecture. And so, having failed to reach agreements, we all went away and had lots and lots of corridor meetings, bar meetings, more bar meetings, lying in corridor meetings on the way back from the bar, that type of thing, until a little piece fell out, and IRS is that little piece. And it follows the theory that configuration of routers tends to be pretty clunky. It's usually not dynamic. If you make a config change, you then have to actually commit that, and the whole config file gets recommitted, and that's not particularly fast. And it's not granular, and hey, it's not standardized. So, with your operator spectacles on, wouldn't it be great if you could configure all routers the same way? There are existing programmatic interfaces, but they tend to target very low level. So if you use OpenFlow, you're down, at the moment at least, talking to the data plane or the forwarding plane. And that's a pretty complex way of configuring a network. And at least the IETF view of networks is that the intelligence is better distributed, and you use routing protocols. So we're looking for a way to do a high-level input and output from routing. And that's sort of, at the very lowest it'll go, it's at the level of the rib, not the fib. It's controlling the behavior of the routing protocols, and in particular, it's playing with policies. What are the policies for policy-based routing? What are the policies for firewalls and security? What are the policies for import and export of routes? And you can see BGP as a particularly prime candidate for that. And at the same time, it's nice to be able to actually extract the topology and routing information from your network in a sort of coherent and usable way, possibly having it pre-filtered in the network. So here's a picture. It's such early days for IRS that I can be sure that this picture is both right and wrong. In that sort of, it's funny, it's green on this screen. In that bluish box on the bottom, marked router, all the white bits are stuff that you already have in your router. You already have routing and signaling protocols. You have probably multiple ribs and a rib manager that is responsible for squidging them into a fib, driven by policy. You've got a lump that will be doing OAM and kicking out events and measuring stuff. And what IRS says, well, let's put in a block in there that can talk to these components and can manipulate them, extract information, and control the way they behave, and put a nice, simple, I think RESTful is the buzz, interface up to clients, so that clients can either be embedded into applications or they can be standalone in servers and have multiple applications talk to them. There was a small skirmish on the frontier about what the word application means, because many people see that as, oh, an application is a piece of software sitting on my laptop. And it's not quite clear that it's as simple as that. It may be that the application is something like a layer 3 VPN or a traffic smoothing tool that may be spread across multiple servers, or maybe a client's view. But that probably doesn't, how this is used probably doesn't affect what we're doing, because we need to build a protocol and a data encoding. And the protocol's easy. Protocols are just, in this type of situation, it's a push-pull protocol. The detail that the devil is hiding in here is the data encoding, and very specifically, what data do we need to encode, and how are we going to encode it in a way that is useful and not so complicated that you couldn't possibly use this interface. So down the line, the big challenge is actually going to be producing information models to work out what it is we need to encode. Before we get there, well, I said, what is an IRS application? How does IRS interact with configuration? Because now we've got two sources of input to this router. We've got all the traditional config stuff. Well, I guess we've got three. We've got stuff coming in from the routing protocols, and now we've got, another one. So we've got to work out where the priorities lie, who can overwrite what the persistency is. We are, at some point, going to have to look at whether we've got existing protocols and encoding languages that do this. Amusingly, within probably 30 minutes of floating the idea of doing this, there were half a dozen people banging on the door saying, but our protocol already does this. So in the IETF, we have forces, we have netconf, we have SNMP. Outside the IETF, we've got tier 1, I guess. Anyone could use XML. The ONF would like us to use OpenFlow. And it's too early to know which, if any of these we'll use, or whether we have to reinvent the wheel. It all depends on what the use cases are and what the information model turns out to be. Big question will be how it relates to OpenFlow. The ONF architecture is quite broad in scope, although the current realization of the architecture is fairly narrow in scope. So you could say that a lot of this fits into the OpenFlow architecture, but it's unclear whether OpenFlow actually forms part of the picture. Again, looking at this, you could maybe put OpenFlow between the IRS agent and the FIB. And the last question, what's it all for, is very important, because there's a great danger of inventing yet another way of configuring routers that nobody will actually use. So unless we're being driven by serious use cases, we won't get anywhere. So, serious use cases. There are lots being suggested, and we're trying to focus onto a few that actually might be killers for us. So, the core routing system behavior, the injection of static routes, which is fairly simple. The control of how you actually build a FIB out of a RIB, and then actually being able to read some of that information back out of your routers, all in a standardized way. It's maybe a little pipe dream, but it'd be kind of neat if it happened. Topology manipulation is probably going to find its traction in multi-layer networks. But the first step is to actually be able to go to a router, find out what topology is there, and find out what the traffic engineering information currently is. Then, with that, you can start building virtual links, tunnels, to manipulate that topology. BGP policy, this was the first the IRS actually came to me, was an American carrier coming to me with my Juniper hat on, saying, we want to be able to define and configure flow specs. If we could do that with your router today, we would still not buy any because we don't have any money because we're an American carrier. But they could really see a benefit to being able to just go in and go to their ASBRs and, in particular, actually to their route reflectors, and play with flow spec definitions and configurations. Firewall policies. again, I think what we're looking here at is a standardized way of doing firewall stuff, being able to build a set of policies and dump them into a firewall without having to know which particular firewall it is you're running. So those are the four that we're currently sort of hugging in the hope that they give us enough focus to do the rest of the work. Four, in fact, seems like quite a lot. And if we were to drop down to 2 or 3, I wouldn't be unhappy. What are we doing? So there are some internet drafts getting posted at the moment with people writing their first view of what the framework might be and their first ideas on use cases. We will meet in Atlanta in November for a BOF, a Birds of a Feather, where the objective is to decide whether or not we've got focus and support. Okay, so this whole thing is not going to happen if people aren't able to focus on doing some work and if there aren't enough people who want to develop it and deploy it. And after that, we will maybe form a working group to run through these use cases and requirements and develop abstract information models. And with that, we can then start to evaluate protocols and write real data models. And then in the slides, you can find some references. We don't have a working group charter to go to yet. That will all come out of Atlanta if we go ahead. But you can start to see some of the documents that are out there. And if you go on the mailing list, people announce their new documents as they write them. And that's me. Anyone awake? I was originally scheduled to be immediately before lunch, so I knew what the answer to "are there any questions" was. Yes, where's the food? Yeah.
Yes, we've got a question.
It's Ben Ward, MLL Telecom. Just interested in CIDR,
Yeah.
being fundamental to the RPKI infrastructure, being the very thing that causes it to work. How do you stop a total infrastructure collapse if the routing is withdrawn that will get you the certificates?
Yes.
So this is like a glue record problem, basically, isn't it?
Yeah, I mean, you do not have to go to the source every time you get an advertisement. Okay, you only have to go there, have gone there sometime, and find out about updates. So stuff is slightly more stable than it might be. But it's how do you get your router to route packets if you unplug it from the internet? So yeah, if stuff falls apart completely, well, you are allowed to continue to operate without doing the RPK, without doing the authentication. Okay, you're essentially, you've got 3 grades. You've got authenticated, authentication failed. In other words, this is a porky pie, and business as usual. So the internet works today, sort of, and what the whole RPKI thing gives you is an incremental on that, and allows you to say, okay, at the moment I can't authenticate this, but I'm still going to use it. Yeah, and I would guess that operationally, that if you keep finding, every time you just want to find out whether this is a good advertisement, you suddenly can't actually access your certificates, then you might want to log that somewhere, because that does seem like a very neat way of making sure that, oh well, yes, we'll just trust this for now.
Okay, I keep seeing a hand popping up at the back as well, and I lost count of who was first. So I said, we'll go with Adrian because I keep seeing his hand, and then we'll go Mike, and then Zoe, if that's okay.
Hi, it's Adrian Kennard again. your comment right at the beginning was that 99% of misannouncements are accidental. So how much do we really need all this signing? And does that create problems? I mean, not just the idea of how do you get the certificates if you've got no routing, but it gives much more control to people like RIPE issuing certificates and things. Then doesn't that create more side effects than the benefit? What you just need is something to stop accidental announcements.
How do you stop an accidental announcement? Well, you train your staff better.
I'm not saying don't have filtering, but you don't need all the signing, do you?
Well, you don't need... so the question is, if you receive an accidental announcement of somebody else's prefix, how will you work out that that is a false announcement? You could look at the other side of it, which is, if you're just about to announce a prefix, how do you check to make sure it's your own? I would say the way you check to make sure it's your own is already in place. It's just not working. It's as simple as knowing whether this is one of your prefixes and you're allowed to announce it. It's not kind of rocket science, but we're still getting the problem. Well, I may be naive. I'm just a user. By the way, you were talking about 8 meg lines. I get half a meg at home. Well, I'd probably move closer to the exchange, yeah.
Okay, so take Mike and then Zoe, if that's okay.
Mike Kelly, Data Centre. With NV03 and ECUPA, presumably in the public case, presumably the assumption isn't that layer 3 is the necessary or the natural place to attach it. It's just presumably that if you want to address it in layer 3, this is the approach that will be recommended.
Yeah, so the question there was, do you need to solve the data center problems at layer 3, or can you solve them at other layers? There is certainly no sense in which anything the IETF does is mandatory.
Fergus has got spare.
And there's a presumption that there are ways to solve some of the data center environments at layer 3. Not all data centers would fit layer 3, I'm certain, but I'm also certain that some will. In fact, there's some Microsoft work where they're jumping up and down saying, well, look, just use BGP and IP and get over it.
While the other microphone's being resuscitated, I'll just go and use this one. There we go.
Hi, Zoe O'Connell. A lot of the ISPs who make errors in their announcements right now are medium-sized providers who perhaps are not great at keeping things like the RIPE database up to date. Do you anticipate there's going to be a problem with uptake, given that that sort of ISP, if you have a system that requires the administrative side to be up to date and they're not good at it, you're turning a potential administrative shortfall into an operational catastrophe when all of a sudden they can't get online? Their entire AS is off because they didn't keep the database up to date.
Yes. I'm actually not completely convinced by the uptake of any of the CIDR work. I think some of it will rather horrifyingly depend on governmental regulation. So if you're fortunate enough to be an operator in the US, the decision about when to adopt CIDR may not be a flexible one. But aside from that, I think, firstly, it's a a step-by-step thing. So you don't need every AS to have adopted. Everything still works. You don't, and you are no worse off today with your advertisements than you were yesterday. But there are sufficient advantages as well in terms of providing good service, in cutting out the false advertisements, that people may feel an incentive to go anyway.
Okay, we've got another question. Yep.
Hi, yeah, this is Gavin Brown from Central Nick. I saw an expired draft from about 2008 on the use of DNSSEC to distribute resources in the cyberspace. I just wanted to give us an update on where we are with that.
I think that has disappeared. It's not impossible, but the feeling was that gluing the certificate distribution to exactly the same tree as DNS is using was not going to be optimal. So there is a new protocol that the working group has been working on specifically for communicating between the routers and the RPKI.
Any further questions? Okay, if there are no further questions, thank you very much, Adrian. Okay.